At the University of Iowa, a sustainability initiative is underway. A key part of this strategy is long-term renewable energy solutions. As a community unto itself, energy consumption is a large part of the university's ecological footprint. As such, the first step to sustainable energy is finding ways to use less.
Renewable energy is good, but arguably the most renewable energy is energy you don't use. So energy conservation is the first thing that we have to look at. We need to reduce the amount of energy that's consumed on our campus. Small changes add up. We've got nearly 30,000 students here, and if they can each turn off a light or turn off their computer, that adds up to some big dollars and some big emissions reductions.
Knowing the impact buildings have on energy demand, the UI makes efficiency a priority of new construction, as well as ongoing building stewardship.
Our greatest contribution is to keep these buildings tuned and calibrated so they're always operating at their highest level of efficiency. We can save more energy that way than any other specific program.
We're trying to strike this balance between saving energy and being comfortable, being functional. Eking out a little bit more energy savings in a design today and spending a little bit more money to get a sustainable design put into place could cause us to save money year after year after year.
One green aspect of Iowa's energy strategy is surprisingly old-fashioned. A combined heat and power system is an efficient, clean, and reliable approach to generating both electricity and thermal energy in a single integrated system.
Combined heat and power has been around for a long time. Thomas Edison built the Pearl Street Station, the first commercial electric generating plant in 18-something in New York City, and it was a combined heat and power plant. He made steam in a boiler, ran a turbo generator with that steam, and took the exhaust from that turbine generator and used it to heat buildings. It's more efficient than generating steam by putting boilers in individual buildings and buying electric from the grid, and that's the real advantage to it.
Another success in Iowa's energy story is biomass. The university takes oat hulls produced by Quaker Oats and burns this byproduct as fuel.
We're able to burn about half the energy in that boiler from biomass. It's an amazing process that we've been able to sustain such a high level of a different fuel than what the boiler was designed for.
On average, biomass represents 15% of the fuel consumed in Iowa's power plant. The success of the biomass fuel project allowed the University of Iowa to join the Chicago Climate Exchange, North America's only cap-and-trade system for greenhouse gas emissions.
We've reduced our emissions about 7% already. That's a savings of about 70,000 tons of carbon dioxide per year that doesn't go into the atmosphere, 30,000 tons of coal per year that isn't burned. It's really a win-win kind of a success story.
Recognizing the connection between renewable energy and economic sustainability, the state of Iowa has emerged as a leader in the development of biofuels and wind power.
We know that fossil fuels are limited. I mean, one day we'll run out, and therefore we have to come with alternative sources of energy. The power that comes from the wind is free, and we can extract as much as 59%, and that power can be transformed into mechanical energy and then electrical energy.
By 2010, the university plans to reduce its energy consumption by 10%. To meet that goal, some of the biggest impact will be made on the individual level.